In this session, we're going to solve the exam paper for 2021 physics. However, I must make mention that in as much as we are going to be solving all these questions, so these are the questions that we're going to solve. So you can be pausing the video and you try out just to maximize your understanding. Then, this paper is for 2021. Provided there are other things that are revised in your curriculum, you might want to skip that part. However, you might also want to keep on watching specifically to those parts which you feel like they are in your course outline. Okay, and that is very, very important for us to go through. Okay, now the way you solve some of these exam questions will be dependent on how your university or your lecturer wants you to solve them. Okay, now we've also been given constants on the first page of the exam paper. Now the way we solve exam questions, it might be different the way we've been solving tutorial sheets and quiz papers and test papers. So in as much as you are watching this video, you might want to be trying out to prepare for that exam, because when you reach at this point, all you are doing is just now revisions. So basically this is how we're going to go. Now I've separated the questions. This is the whole exam paper, question 1 to 7, and with some multiple choice. Now I had to separate them into some components so that we leave space for solving, because others are longer than others. Okay, so basically these are just some of the basics that I wanted us to know. Okay, so without wasting much of the time, we're going to start with the first question. Now on question number 1, we are told that the magnitude of the resultant of two forces is minimum when the angle between them is dash. Okay, so when the angle, we're talking about the magnitude, okay, of the resultant of two forces. Now they're asking us is minimum when the angle between them is what? Okay, so how are we going to find the magnitude? You know that we define the magnitude of two forces as the square root, according to your Pythagoras, the square root of, if I've got a to be a squared, but in this case, since we're talking about forces, let me just say your force 1, you are going to square it, plus force 2, you are going to square it like that. So now if we're going to say we're finding cos 0, cos 45, cos 90, and cos 180, let's just try to find out. Okay, so if we're going to find the magnitude of an angle, you know that cos 0, you know that gives us a -1. Okay, now cos 0 only occurs at 180. Okay, so we're saying cos 180 gives us a -1. Okay, that is the slowest or the minimum that we can have, because if I've got another cos 180, it also gives me a -1. Now -1 plus -1, that will give me a -2. This is the smallest that we can have, so our answer in this case is D. Now let's also prove the other ones. Now cos 0 gives us a 1. Now if we have two forces, we're going to have 1 plus 1, which will give us a 2. Okay, this is maximum. The other one gives us a negative. For 180 gave us a -2. Now what about cos 45? You know that from your trigonometry, you know that cos 45 is equals to 1 over root 2, right? Now if I'm adding this to 1 over root 2, you know that 1 over root 2 is just a very smaller number. Okay, even this one, and when you add them, but they will still give us a number that is greater than a negative. Okay, basically this will be maximum. Okay, same with 90. Okay, because it's 45 plus 45. Okay, it will also give us a number that is not a negative. So basically the one that is going to give us the least in terms of calculations, it is 180, which gives us a negative answer. So basically for A it is D. Let's come to now B. We are saying a ball dropped loses potential energy. Gravity is an example of dash. Okay, but that is really true. If let's say this is a ball, okay, you've dropped the ball and it's going down and it's going to the ground. Now you know that potential energy, we say it is mgh. Okay, now as you are going down, you are losing height. Okay, because you are losing that height, it means you are losing kinetic potential energy. However, what about gravity itself? Are you losing gravity? Is gravity going to be conserved or not? Is gravity going to be displaced? Then the other I'm talking about a reference level. Okay, basically gravity is about 9.8. So at every point as this ball is dropping, gravity will still be 9.8. As you are going down, gravity will still be 9.8. Only the height is going to be changing. Okay, therefore in this case our answer is it is B. Gravity is a conservative force. Okay, so other conservative forces that we have like elastic forces, like maybe from a spring. Those ones are conservative forces. However, there are other non-conservative forces. When you're talking about non-conservative forces, meaning these forces, they don't, conserve the total amount of forces that you have. Okay, so non-conservative forces like friction. Okay, in this case of a ball that is dropping, this will be the friction will be due to air resistance. Okay, so such kind of forces, they are non-conservative and they will depend on the path that we've taken. Okay, and mechanical energy that is lost as heat, all those kinds of forces are non-conservative. Okay, basically this is our B. Now let's solve C. Now for C, we are told that the acceleration of gravity on the planet mass is 3.7 meters per square second, compared with her mass and weight on Earth. An astronaut on Mars has dash. Okay, so what is our answer for C? What do we know about mass? What do we know about weight? Okay, now you should know that mass is an intrinsic property. Okay, it does not change with location. So the mass that you are going to have, if let's say I've got 20 on Earth, if we take you to the moon, it will still be 20. Okay, so the mass is going to be the same. So automatically we cancel this one, we also cancel this one, then automatically you can also cancel the last one, because less mass, no, the mass will still be the same. So our answer in this case, it is C. Okay, so that is very, very important for us to know. Now what about weight? You know that weight is equals to mass times acceleration due to gravity. Since we are saying mass does not change, however the gravity itself can change. Okay, we've been told that the acceleration due to gravity on mass is 3.7 meters per square second. Basically that is very small compared to the one that we have on Earth, which is about 9.8. So able to see that weight is changing. Weight can change, okay, based on the acceleration due to gravity. So basically that is important for us to know. Okay, so our answer therefore in that regard, it is C. Now we come to D. We are asked that the coefficient of kinetic friction, the coefficient of friction is defined as dash. Okay, what do we know about the coefficient of kinetic friction? Now you know that friction force is equals to nu multiplied by the normal force. Okay, now the nu in this case is the coefficient. The coefficient will be dependent. If it's the static, if it's the friction due to static, it will be S. If it's the friction due to kinetic energy, this will be K. Okay, that is the coefficient. Now we're trying to find what the coefficient is based on this equation. So if we're going to make ratios here, we're going to divide by the normal force on both sides to make our coefficient the subject. So therefore our coefficient will be equals to the friction force divided by the normal force. So let's now look at our answers. So we are told that number 1A is saying the ratio of the force needed to induce motion to the force needed to maintain the motion. Okay, this doesn't make sense. It's not the answer. Then B was stated the ratio of the pressure. Okay, pressure is not applied here. C was saying the ratio of the frictional force to the normal force. Yes, force over friction. C sounds to be correct. We can mark it. What about the last one? The ratio of the normal force to the frictional force. Actually, this is the opposite of what we want. So basically, our answer for D is C. Okay, the ratio of the friction force to the normal force. Friction force to the normal force. So basically, this is how you solve the first set of 4 questions. Okay. So that is very, very important for us to know. Then you should also know that the coefficient of kinetic friction, it varies with different surfaces. Okay, so usually for static friction itself, it is usually generally higher, okay, than the one for kinetic friction. That you should know. That is very important for you to know. And the range usually is from 0 to 1. Okay, basically. But if it's 1 or greater, it means that there is a lot of friction there, and that is very important for us to understand. Now we're going to question number E. We are told that the work done in lifting a 30 kg of bricks to a height of 20 meters on a building under construction is dash. Okay, basically we're talking about the work done in lifting 30 kg block under construction. Let's say these are 30 kg, and we are lifting it to a certain height. The height in this case is 20 meters. Okay, and this block, this is 30 kg. Okay, now the work done in lifting, that the work done in lifting in this case will be due to potential energy. Okay, the potential energy in this case, it is the mass multiplied by the acceleration due to gravity. 9.8. I'll get 9.8 multiplied by the height. Let me multiply. Okay, this gives me 5,880 joule. This is what we have as the work done. Okay, so that would be the work that will be done. However, since we are doing exam preparations, you should also know that for this case, provided there is no friction, provided there was friction, there's going to be work that is going to be done by friction, provided we do not neglect the air resistance. Okay, for this question we're talking about air resistance. However, there are scenarios where you have work done by friction. Okay, let's say you're moving on an incline. The same scenario, you're going to have a height. Okay, this object, since maybe you're pushing it in that direction, you're going to have friction that is going to be opposing it, provided this is a surface with friction. Okay, then you're going to have a certain height that this object is going to move. Yes, you're going to have potential energy. That is important for us to know. You're going to have the work that you're going to do due to the force that you're applying. Okay, you personally as an individual. However, the object itself is also going to do work Now that work is called work done by friction because there's a friction force that is going in the opposite direction. So you're also supposed to find that, and that is very important for us to also understand. Regardless, then the period of a pendulum, of a simple pendulum, is independent of dash. The period of a simple pendulum. So now you have to recall that the period of a pendulum, especially for those small oscillations, you know that period is equals to 2 pi. Now this 2 pi, you are multiplying it by the square root of your length multiplied by the acceleration due to gravity. Okay, so now from this, what are you able to see? So you have to identify which quantities affect the period itself, okay, from this equation. So you're able to see that this t is dependent on the length, okay. Then you're able to also see that this t is also dependent on g, okay. So it's dependent on length, it's dependent on the acceleration due to gravity. Now what other thing but now you're able to set in this equation we don't have mass, okay. So because we don't have mass might be a potential answer, okay. What about the total energy? Okay, so usually energy might also affect it, right? Okay, so especially for small swings, okay, so that will be like very, very important for us to understand, okay. So in real pendulums with large angles, the period will slightly increase with a certain amount of amplitude, okay. That means at very high energies, the period, it just becomes amplitude dependent. So energy can also affect the period of a pendulum. And period is just the time it takes, okay, the time it takes for this pendulum to complete one full oscillation. It goes, it comes back, it goes, it comes back, okay. That's like a complete revolution, okay. So that is very, very important for us to also understand. We move on to a second set of questions. Now I thought that the moment of inertia of an object does not depend on dash. The moment of inertia of an object does not depend on dash, okay. Now you must understand that what is inertia. When talking about inertia, it's an object's ability to resist motion, okay. That is very, very important for you to understand. So that resistance by an object to resist motion, if an object, according to Newton's law, if an object is standing, it always wants to be in this state. Any force that tries to push it, it will always want to maintain this state. Therefore it's going to resist, okay. That resistance is what we're calling inertia. Then another scenario is if an object is moving in this direction, okay, if it's in motion, it always wants to be in this motion, okay. Any force that comes to counter react, it will be faced with a lot of opposition. Basically that's about inertia. But now when I talk about the moment of inertia, the moment of inertia will be, let's say an object is rotating, okay, around a certain axis, okay. So it is rotating, any force that is trying to oppose it in that system of rotation, it is going to be opposed, okay. So that is very important for us to understand. So now what will be, what will this moment of inertia depend on? Of course it is going to depend on the it is going to depend, yes, on the mass, okay, the size. How big is this? Because a bigger object and a smaller object will be easier to push if it's just seated like that, if it's just on a plain ground, or because its moment of inertia is smaller if we're going to compare it with a bigger object like this one, okay. So it will be very hard for you to push a bigger object than a smaller object. So the size, also the shape, okay? So the shape will be dependent if is it this, is it a circle, or let me say a ball like that, any shape, okay? Those are going to affect. Now what about the mass? Yes, how much something weighs is going to also affect it, okay? What about the speed? The speed, no, okay? The speed has got nothing. What if it's just not moving, okay? The speed might not affect if it's moving. However, what if it's rotating at a certain speed? Is it going to affect how you do that? Of course not, because the way you find your moment of inertia is equals to, is it mr squared, okay? Now the r squared is the distance from the moment from the axis of rotation, okay? So it's going to be dependent on the mass and the axis of rotation. There is no speed here, so basically that speed is our answer in this case. So the location of the axis of rotation is going to also affect it, okay? Is it at the center, is it far away from the center? All those things are going to affect it. So for G, our answer is angular speed. We come to H, the total angular momentum of a system. The total angular momentum of a system of particles changes when a net torque acts on the system, remains constant under all circumstances, changes when a net external force acts on the system, may or may not change under the influence of a net external torque depending on the direction of the torque. Okay, so what are we talking about? So the angular momentum, you know that angular momentum in this case usually it is equals to a moment of inertia multiplied by the angular velocity. Okay, now when we're talking about angular momentum, we're talking about the first one is saying changes when a net external force acts on the system. Okay, this might be correct. Remains constant under all circumstances. No, it doesn't remain constant. Changes when a net external force acts on a system. Changes when a net external force acts on the system. Changes when a net, it looks like it's the first one. A and C look like they are the same. Okay, now I've seen. One is a torque, one is a force. No, force has got nothing to do with this. May or may not change under the influence of a net external torque depending on the friction. No. So our answer in this case is just A. So the total angular momentum is conserved when no net external torque acts on it. But if you have a net external torque acting on the system, it changes the angular momentum. So external forces that produce torque, a pivot, because torque, it is a turning point, a turning of a moment. Okay, so now you want to rotate, and there is a certain amount of speed. However, as you are going to be rotating, okay, because that is the torque, the turning point. So the torque can be be influenced by other things, like at which point is this object rotating at? It's at the pivot, right? So examples like those things they might not affect the torque. So basically those are some of the things that you're supposed to understand on this question. Now we come to I. In an equilibrium problem, the point about which torques are computed, okay, the turning points, the pivots, in an equilibrium problem, the point about which torques are computed must pass through the object center of gravity, okay, may be located anywhere, must pass through one end of the object, must intersect the line of action of at least one force acting on the object. So our answer here is B. Okay, so what you should understand is that the pivot, okay, in an equilibrium problem, especially when you're dealing with these turning points, which is the torque, it can be located anywhere. Okay, so it can be located anywhere. You can choose any point as a pivot in torque calculation. Okay, that is very important. Then what you should understand is that rotational equilibrium requires the sum of all the turning points about a point, about that point to be zero. Okay, there is no requirement that the pivot passes through the center of gravity, okay, or a specific force line of action. That is very important for you to understand. Then we've got J. Gamma for a gas is defined as the ratio of dash. Gamma for a gas is defined as the ratio of dash. Okay, now what you should understand is that when we're talking about gamma for a gas, gamma will be equal to the specific heat. Specific heat is C, right? We usually abbreviate it as C. So it will be C. So this will be specific heat at constant pressure, okay, divided by the specific heat at constant volume. Okay, so it usually it will just be a relationship between the specific heat, you know, at a constant pressure and specific heat at a constant volume. Okay, so in this case we've got the first one is wrong. What about this one? No, this one is opposite of what we want. So our answer in this case is C. So basically this is how you solve these multiple choice questions in an exam. Okay, cancel the ones that you feel you can cancel them, then those ones that you feel you can't, don't. Okay, so basically now let's solve some question 2 type of problems. Okay, where you now solve. Okay, most of these ones are they have a lot of marks, so you must at least maximize when you are solving this type of questions. So now we are going to attempt any 4 questions from below. So how many questions are there? We've got 2. Don't forget the numbering, because the numbering mostly they begin with 2. Okay, so I don't know why they begin with 2, but don't start now asking why do they begin with 2. Just choose your questions, 4 of them, and solve. Okay, so question number 2, we got 3, 4, 5, 6, and 7. Okay, so in this case we've got 6 questions. So you're choosing from the 6 questions, you're choosing 4. You're leaving 2. Okay, now what I should make understand is that you might never know everything. Okay, so go for the questions that you feel you're going to exhaust all the answers. The questions that you are very much confident about, those are the 4 questions that you are choosing. However, they can also put questions that you might not be familiar with, or maybe you might never have learned. Okay, don't say I never learned this. Yes, you might have never learned that, but choose a question that you feel like, okay, this one I can try. Okay, basically they are going to bring at least 4 questions that you learned, okay, on maximum. They maybe bring one that might require you to just analyze how you analyze certain things, and maybe they might just bring others as general knowledge questions. So basically this is what you do. So let's start with the first question. So what have we been told? We are told a car is driven east for a distance of 50 kilometers. Let's say this is east for a distance of 50 kilometers, then north for 30 kilometers. Okay, now if it is north for 30 kilometers, let's say this is 30 kilometers, and lastly in the direction 30 degrees east of north. If I'm going to draw an axis here, this is east, this is north. Okay, So east of north, in this case, they've told us 30 degrees. If this is 30 degrees, this is 30 degrees, like that. Find the total displacement. Find the total displacement of the car from its starting point using the vector method. Okay, basically this is what we have. We might not even want to put all the things. So what are you supposed to know? Now you've been told that. I just want to explain on something. This is the north, this is the east, this is the south, and this is the west. Now what do they mean when they say north of east? Okay, and what do they mean when they say east of north? What do they mean when they say south of west? And what do they mean when they say west of south? So basically, when you know this, you are good. So if we say north of east, what this means is that what is the north of east? Okay, or from the east, where is the north? Okay, so basically, if they haven't given you the angle, you're just going to get the middle ground. Okay, in this case it will be 45 degrees. Okay, and the other part will be 45 degrees, but you're getting one. But now, in which direction are you going to measure? They are saying north of east. So north of east, you're going in the direction where the north is, because that's where you have the north of east. That's the angle that they want. So basically, that's how you're going to find this one. Okay, now what if they say now east of north? Okay, east of north, you know that the north is this side, so you're moving from the north, you're going to the east. Okay, basically this is the angle that they want. Then if they say south of west, now south of west, if this is the angle, it's going to fall in the third quadrant. Now south of west, you're moving from the south, you're moving from the west going to the south. So this is the angle that they want. Then for the last one, if we say south, west of south, okay, west of south, if this is the angle, you're going where the west is, meaning this is the angle that they want. Basically, this is very important for you to understand. Now that you've understood that, how are we now going to solve the first question? So we're trying to find the total displacement of the car from its starting point using the vector method. So basically, this is vectors most of you are very, very much familiar with. And let's start with the first one. I'm going to call it the first leg. We are told that it moved 50 kilometers east. Okay, that was the distance that it moved. Okay, so for the 50 kilometers east, and if we say going this side is positive, going this side it is negative. Since in the eastern direction it is this direction, so we're going to say it is positive, and that is in the x direction. So what will be the component for the x and what will be the component for the y? So the change in x, let me call it x1, will be equals to just 50 itself. Okay, what about the change in y? Okay, the change in y for the first one will be what? 0, because we're only moving in the x direction. So basically that is very important for us to understand. Let's come to the second leg. So second leg. So for the second leg, we are saying then north to for 30 kilometers. So it moved, we are saying 30 kilometers north. So this is the north. Now if it is in the north and we take up going as positive, coming down as negative, so basically since it's going up it will be positive. However, what are we going to have as our x component and our y component? You're able to see that going up it is the y axis. Okay, therefore what will be the value for the x? For the x, we're saying this is the north. So the change in x, for let's say this one is x2, what is it going to be? It is going to be 0, because there's no there's nothing in the x direction. However, in the y, this we are going to call it change in y2. We are saying that it moved 30 kilometers. Okay, now let's come to the third leg. We are told that it moved 25 kilometers at 30 degrees. Okay, at 30 degrees east of south, east of north actually. Okay, so now you know that it's going to be an angle that is going to be produced there. Okay, if this is the north, this is the east, we've said if this is our angle, this is 30 degrees east of north. Okay, it means you're going in this direction, and this will be your 30 degrees. So this, you're going to resolve it into its component. The y component, this is the x and this is the y. So you know that for the x component, you know that it will be 25 cos theta. Theta in this case is 30. What about for the y component? The y component will be 25 sine 30. Okay, basically these are the basic principles that we learned from our SOHCAHTOA. Okay, so basically what are we going to have as our x and the y component? So for the eastern component, in this case, let me call it east component, the one that is in the x direction. Okay, what are you going to have? It will be 25. We're saying it is 25 sine 30. In this case, we're saying it is 12.5. Okay, then the one, okay, this is for the one that is in the eastern direction. Okay, yeah, this is for the y component. Okay, that is very important. Then for the x component, we're going to have 25 cos 30. 25 cos 30, what does it give me? It gives me 21.65. okay, that is what we have as our answers. Now what are we now going to do? We are going to add all the x components and all the y components. For what is the total for the x components? So the total for the x components, if I'm going to start adding now, I've got what? 50 plus the 0. What other thing do I have? I have plus, in this case, what? I've got the 12.5. okay, then what about for the y component? Change in y, in this case we're going to have what do we have? We have a 0 plus, we have what other thing do we have? We have a 30 plus a 21.65. okay, so basically this is what we are going to like have. We always consider a direction. Okay, now if this is what we have, mind you, just to remind you, this is the thing that we had made, so we have to make sure that we find the components. Okay, so it's going in both directions, so we are adding them. Okay, one will be the x component and the other one will be the y component. So this is the angle that we have. Okay, for us to find us the x component, we know that if this is the, let's say okay, what do I want to say? We've been given 30 degrees. Okay, this is a x, this is a y. Okay, and we're trying, this is the x, this is the y. Okay, so 25, which is the hypotenuse, so 25 sine 30 will be equals to SOHCAHTOA. Okay, let me not assume, let's just remind ourselves. SOHCAHTOA, so sine is equals to opposite over hypotenuse. Okay, so opposite to 30 is the y component. Okay, so sine 30 like that is going to give us that. What about cos 30? Cos 30, and then if you're finding the cos, it will be the adjacent over the hypotenuse. Where is the adjacent? You're able to see that the adjacent is here, okay, over the hypotenuse. That's why for the x component, we're going to have that 25 cos 30. Okay, then we add. Then if we add these figures, what do we have? This is giving me 62.5 kilometers. The other one is giving me 51.65. Okay, these are the figures that I have. Now I'm trying to find the magnitude. So let's find the magnitude. We know that the way we find the magnitude of this vector now, the magnitude will be, since we found what we have as a change in all the direction, so the magnitude in this case will be equals to the square root of 62.5 squared plus 51.65 squared. Now that will be the square root of 62.5 squared. What does it give me? Okay, that gives me like 3906.25 plus 51.65 squared, it gives me 2667.7. okay, basically that is what I have. Since I already have my 2667.7, I'm just going to add that by 3906.25. I'm getting 6573.95. Then the square root of that, it gives me 81.1 kilometers. Okay, now that I've got this, I'm also supposed to find the magnitude, the direction. Even if they haven't asked you to find the direction for a vector, please always find it. Okay, and you know that the way we find the tan theta is just equals to, the one that you have as the change in y over the change in x. In this case, tan theta, what are we going to have? It will be the theta will be equals to be the arctan, okay, the tan inverse of the change in y over the change in x. So what are we going to have? So in this case, what do we have as the y? We found that is 51.65 divided by 62.5. okay, what do I have as that? So I'm finding the inverse of that, the arctan of that. So 51.65 divided by 62.5. okay, the answer, and the fact the arctan of that, I'm finding my angle in this case as 39.4 degrees. Okay, so basically this is what I have in the north of eastern direction. So therefore what we mean is that the answer, the final answer, the way we're going to write the final answer, because you know that these are vectors, forces are vectors. Okay, however in this case we're going to talk about what this will be 81.1 kilometers at 39.4 degrees north of east. So that is very important. The north of east changes everything. Okay, it changes everything. So that is very, very important for us to know. Okay, that's why we've changed like a lot of things. It's not the way you solve it, the way you've been solving vectors initially. This is a very different case. Okay, now we come to B. So excuse me for that. So now we're told B, for the setup shown in the figure below, find the tensions T1, T2 and T3. Now if I'm going to say, since our diagram is not very clear, if I'm going to say this is T1, this is T2, this is T3. Okay, however you're going to put them, those are just the tensions. Okay, now then number 2, we're taught to state the two conditions of equilibrium. Okay, now if we're stating the two conditions of equilibrium, let's talk about the last one first. The two conditions for equilibrium, for a body to be, in equilibrium, what are some of the things that you're supposed to understand? Numbers, you have to understand that the summation of all the forces should be equal to 0. Okay, when you add all of them, let me say you have a force that is acting maybe 30 degrees or 30 in this direction, it is negative. You have another force that is acting in the other direction, in this 30 positive, like that, positive 30. Okay, all the forces in this case, they'll give us a 0 when you add them. But if we have another force that is acting, let's say a 20 also in this direction, the net force, when you add all of them, you're just going to have 20 in that direction, which is positive. It's 20 positive in that direction. There is no net equilibrium here. So for you to achieve equilibrium, all the forces must give you 0. Condition number 2, this is condition number 1. Condition number 2 is that there should be no net rotation. Okay, like in this diagram, if this one rotates, it will affect everything. Okay, by this case, everything might be in equilibrium. Okay, because they are balanced forces. But if one just tilts, okay, it means equilibrium is not reached. So what do I mean? The summation of all the torques, okay, or rotations should be, we're talking about torques, the turning moment, the turning of a force should also be 0. These basically, these are the two conditions that you should always consider. Okay, now that we've got this, let's now solve these questions. So for the setup shown in the figure below, T1, T2 and T3, those are the tensions. So what do we have? So people solve these questions differently in different so let me say T1. Okay, so these are the forces that are in equilibrium. So if we're going to look at T1, for T1, the rope at 60 degrees to the vertical, to the left side, actually, this one. So it is that we have 60 degrees. T2, the rope is at 50 degrees on the right side. For T3, it's the one that is holding all the forces, and you're able to see that it is going down in this case. You know that is about 180 because we haven't been given. But now, what I'm supposed to understand, they've told us this T1 has about 600 Newton weight. Okay, so that is very, very important for you to know, because all the forces are going down. Now let's do tail to tail angles. So tail to tail angles, tail to tail angles of what we have. Okay, so let's start with between. We have to make sure that all of them, because we want this object to be in balanced, so we have to make sure that all the combinations are represented. Now let's start, for them to be represented, let's start with T1 and T2. Okay, then we're going to go to T2 and T3. Then the last combination is T3 and T1. These are the tensions, the forces in these ropes, and we're asked to find the tensions of T1, T2 and T3, all of them. So for T1, we've said it is 60 degrees. Okay, so we're going to add it with the 50 degrees. 60 plus 50, you know that gives us a 110 degrees. When you come to T2 and T3, Now between T1, T2 and T3, you're able to see that this T3, it is 180. Okay, since it's 180, and if you are going to look, it is the one, what do I mean? This is the head of T1, and this is the tail of T1. This is the head of T2, and this is the tail of T2. Now the tail of T2, and if you look at, this is the head of T3. Okay, T2 is trying to oppose, is trying to, hold in that direction. T3 is trying to push in the other direction, okay, because it has a force there of 600 newtons. It has a weight. So basically these ones are subtracting each other. Okay, so in this case T3 is 180, so I'm going to say 180 minus for T2, what do I have? We said it is 50 degrees. 180 minus 50, that gives us 130 degrees. Now I've got T3 and T1. This is supposed to be T1. Okay, those are the combinations that we have. T3, we're also able to see that this is the head of T1 and this is the head of T3. So T1 is trying by all means to go in that direction. T3 is also, it has a force going in that direction. So basically what are we going to do to the angles as well? We're going to subtract. So it will be 180. For T1, well, we've said that it is 60. Okay, now when we subtract 180 minus 60, that gives us a 120. So these are the tail to tail, arrangements that we have. Now that we found the tail to tail, now we have to find now the what do we call the force of the interior angles. We found everything that is outside. Now what about inside now? Because we're trying to achieve equilibrium both inside and outside. So the force triangle interior angles, in this case tail to tail angles. Okay, so what are we supposed now to do? So because all the interior angles, they are being opposed by this force T3. And what is T3? So let's start. Opposite to T1, opposite to T2, and what other thing? Opposite to T3. Okay, so we're trying to, these are the interior angles that we've added. However, we also have to find their opposite. Like we've said, the net forces, they are the ones that are adding up, and the ones that are subtracting. The ones that are acting the opposite, they should give you the same answers. Okay, for you to achieve equilibrium in this state. So what are we going to have? So what is opposing our T1? It is the 180 angle. Then for the T1, we had a combination of T1 and T2. What did it give us? It gave us a 110. Okay, so what we're going to be doing, we're going to be doing 180 minus each tail to tail angle. Okay, so basically this is the first tail, this is the third, and this is the fourth. So from 180 we're going to subtract a 1. Let's start with a 110. From 180 again, for the T2 we're going to subtract, what did we find for the T2? We had 130. Then for the last one we are going to say 180 minus, what did we find for the last one? What did we say for the last one? What am I rating? Okay, 180. Okay, opposite to T1, opposite to T1, what I wanted to say is opposite to T1 we have T2 and T3. Okay, opposite to T1 we have T2 and T3. So basically those are the angles that are opposing T1. Okay, so we are going to subtract minus the one that T2 and T3 gave us a 130. Okay, so I'm going to subtract a 130. That is for T1. Then opposite to T2, it is the same principle. This is T2. T1 and T3 are in opposition to T2. So what did T1 and T3 give us? They gave us a 120. So basically that's what we're going to subtract for T2 minus 120. Then for the last one, 180, for T3, opposite to T3, we have T1 and T2. What did T1 and T2 give us? They gave us, so this will be minus, they gave us a 110. Basically this is what we have. Now for T1, in this case the opposites, 180 minus 130, that gives me a 50 degrees. For T2, what am I going to have? T2, 180 minus 120, that is a 60. For T3, 180 minus 110, that is a 70 degrees. Okay, now that we've got this, what do we now have? Okay, basically now that we've got that, we're now going to bring the aspect of the sine rule. Okay, now you know that for the sine rule, T1, which has the angle that we found, the angle for T1 we found that it is this one. Okay, so we're going to say it's the way we're going to find the angle to be sine 50 degrees. That is for T1. This should be equals to T2. Now what did we find as T2? T2 we had to find that it was 60 degrees in the opposite direction, so this will be sine 60. This will be equals to T3. What did T3 give us? A 70. So I'm going to say sine 70. Okay, basically this is what I have. Now we're going to use T3 to find all these angles, because you're able to see that T3 they've already given us that it is 600 newtons. Okay, so I'm just going to equate this one to be equals to that. We find the answer. Then this one to be equals to that, because they are all equal. They are supposed to be all equal for us to find the to achieve that equilibrium. So now what do we now do, or what do we have now? If I want to find T1 over sine 50 is equals to T3, which is 600 newton, multiplied by sine 70. Okay, now if I solve those ones, what am I going to now have? Okay, so let me first find what sine 600 newton divided by sine 670 is. Okay, 600 divided by sine 70, it will be 600 newton divided by sine 70. What does it give me? It gives me 0.94. Now 600 divided by 0.94, it gives me 638.7. This will be Newton. So basically this is what I have. So I'm going to replace this so here where there is that. So we're saying this is 638.7 Newton. Okay, that is what we have. Now for me to find my T1, therefore my T1 will be equals to sine 50. I can find sine 50 in advance. What is sine 50? Sine of 50, it gives me 0.766. This will be multiplied by 638.7 Newton. So what am I going to have as the T1? So the answer that I have, 0.766 multiplied by 638.7. I'm getting 489 Newton. Okay, we found that. What about our T2? So T2 over, we're saying it is sine 60, will be equals to the one we found, which is this one, 638.7. 638.7 Newton. Okay, now that we've got this, so T2 will be equals to, so we're multiplying sine 60 multiplied by 638. So basically, what is sine 60? Okay, sine 60 gives me 0.866. We're multiplying this by 638.7. So I already have my 0.866. I'm going to multiply it by 638.7. It is giving me T2 as 553 Newton. So basically, these are the forces that we have that are acting on this object. Okay. So T1 is this, T2 is that, and T3 we've already been given. The tension is 600 Newton. Okay. So basically, we're not even finding T3 because it's already been given. So that's how I solve this one, and there's different methods that you're going to use. Now let's come to question number 3. We are told that a girl throws a ball vertically upward at 10 meters per second from the roof of a building 20 meters high. She throws a ball vertically upward. Okay, how long will it take the ball to reach the bottom? Okay, how long is time, right? So we're trying to find the time. Now if you're going to choose, if it is it is thrown upward, if we're going to choose upward as positive and going down on as negative. Okay, basically that's what we're going to do. We're going to choose upward as positive. Now what is the initial height? From the roof of a building of 20 meters, building 20 meters high. Initial height, we've been given that it is 20 meters. What is the initial velocity? We've been given that it is 10 meters per second. It is thrown at that velocity. Okay. Then what other thing do we have? You know that from your equation of motion, yt is equals to y initial, because we're going in the y direction. Okay. So we have to make sure that we're going in the y direction. Otherwise, if it was x, I would have said xt is equals to x initial. However, we're not going in the x direction. We're going in the y direction. Plus, we're going to now have your ut plus half a t squared. Now, because it's under the influence of gravity, what are we going to have? Now, are we supposed to put a plus here? That is the question. We're going to put a minus. Why are we putting a minus? This we're saying it to be half gt squared. Why? Because the exertion due to gravity going down, it is a negative. Okay. In this case, if we've chosen up, going up as positive. Okay. So basically, this is what we have. Okay. Now your yt will be equals to 0 is equals to what is your y initial? It is also not there. Okay. Then what do we have? We have our we have our initial. We've been given that it is 10. This is multiplying by the time, okay, which we are trying to find, minus half. Gravity is 9.8 multiplied by the time that we are trying to find. So what are we going to have? We're going to have 0 is equals to 10 multiplied by actually the initial height they've given us. So the initial height we've been given, it is plus 20. We are not supposed to forget that. So we are going to have 10t. Okay, 10t minus, okay, what the half of 9.8, what does it give me? 4.99t squared. Okay, I'm not supposed to forget the t squared. Okay, so this is what we have. Then what are we going to do? Plus the 20 meters height. So basically, if this is what we have, what do we now do? I'm now going to put the like terms together. Okay, and you know, this is an equation, or I can just put it okay, I'm going to take everything to the other side so that I have positive numbers. So when I take this one to the other side, which has a square, I'm going to have 4.9 t squared minus 10 t minus 20 is equals to 0. So basically this is the equation that I have. Now I'm supposed to solve it using the formula method. Okay, now what is t in this case? You know that t or x is usually positive or minus positive or minus the square root positive or minus b. Okay, the square root of b squared minus 4ac is equals to that. Now over 2a. So that is what we have, just to remind you. So I'm just going to do it direct. In this case, we're going to say positive or minus. Now we already have a 10, positive or minus. We already have a negative 10 as our b. So it means we're just going to have a positive 10 here. Then we're going to have positive or minus. Or it's negative b positive or minus. What am I writing? Yes, that is the quadratic formula. Then what do we now have? Positive 10 positive or minus the square root of b. So I'm going to say the square root of what is our b? It is 10. 10 squared is negative 10. Negative 10 squared, that is 100. Okay. Then what are we going to have? Minus 4ac. Okay. What is our 4? We are 4 multiplied by a which is 4.9 multiplied by c which is negative 20. So meaning the negative is going to cancel. We're just going to have a positive. AC 4 multiplied by 4.9 multiplied by 20. What does it give me? It's giving me 392 over 2a. Our a, we're saying it's 4.9, and 4.9 is a half of 9.8. So in this case, this one is 2 multiplied by 4.9 gives me 9.8. Okay, basically this is what we have. So we're going to have 10 positive or minus the square root of 100 plus 394. Now 392, 100 plus 392, that is just 492. Now the square root of 492, what does it give me? Okay, let me just write it here. The square root of 492 over 9.8. Okay. Now since we want time, I'm going to discard the negative one. I don't want the negative answer. Okay, so in this case I'm just getting the positive answer. So it is 10 plus the square root of 492 divided by 9.8. What am I getting? So I'm getting t to be equals to 3.29 seconds. So basically that is the time that is how long the ball is going to take to reach to the bottom. So t is equals to 3.29 seconds. Okay, now that we found our t, we've been asked what will be its velocity when it strikes the ground. Okay, what will be the velocity when it strikes the ground. Okay, so what do we have? You know that V is equals to ut plus, now because we're going to say minus gt, because going down you said it's negative and the gravity is negative. Okay, V is equals to ut plus that. What am I writing? The equation of motion. V is equals to u minus gt or at. Okay, so in this case the V, what are we going to have? The initial given that it is 10 minus the acceleration, which is 9.8, multiplied by the time that we're just from finding, that would be 3.29 seconds. So therefore I'm going to have 10 multiplied by 9.8, which is 98. No, it's minus, actually this is minus. Let me just do it using my calculator. 10 minus open bracket 9.8 close multiplied by 3.29 seconds. Okay, I'm finding negative 22.2 meters per second. So basically this is what I'm finding. So you can also be trying these figures. Okay, maybe we might have made a mistake somewhere. So that's how you solve the first question. Okay, B. Okay, the spring constant. So we are now talking about the spring constant. So what are we solving? We are told that one end of a spring constant K is equals to the spring constant. We've been given that it is 1200 Newton meter, 1200 Newton meter, is fixed to a rigid wall, and the other end is connected to a 3 kg mass. 3 kg mass on a frictionless horizontal surface. The mass is pulled horizontally a distance of 2 centimeters from its equilibrium position and release. Calculate the frequency of oscillation. Okay, so we're trying to calculate the frequency of oscillation. You know that frequency is measured in hertz, right? Or per second. Okay, so if that is the thing, or what do we have? Okay, so let's first find what we call the angular frequency, and now from that you are able to find now the actual frequency. So what are we now going to do? Now the way we find the angular frequency is the square root of in this case we're talking about K over the mass that you have. Okay, so in this case I'm going to have the square root of the spring constant. It is 1200 Newton meter over 3 kg. Okay, now I'm not going to concentrate much on the, I know what it's going to give me. 1200 divided by 3, and the square root of that, 3 into 12, that's 400. The square root of 400, that gives me a 20. When I multiply 20 by 2 times, that gives me a 400. So I'm going to have 20. Now you know that your angular velocity is measured in radians per second. Now that we found the angular frequency in this case, we can also find now the ordinary frequency. Now the ordinary frequency, because we've already found the angular frequency, so it will be the angular frequency divided by 2 by radians. Okay, so now that we've got this, we have 20. What do we have? What am I writing? Multiplication. So this is multiplication, 20 radian per second over 2 pi. Okay, that's what we have. So therefore when I now divide 20 divided by 2 pi, First 2 pi, then 20 divided by 2 pi is giving me 3.180 Hz. Okay, so this is the frequency that we want. So let me just write it here, 3.180 Hz. Okay, we found the frequency. So others have got this topic, others don't have it. Okay, so this is a part where I said if this is not part of your curriculum, you can jump and or maybe even speed up to the next question. Then B will try to find the maximum speed and the maximum acceleration. Okay, so what will be the maximum speed? You know that V max, which is the speed. Okay, speed in this case when we're talking about in the spring constant, okay, it is going to be the amplitude that you have. Okay, how high, that will be the the distance, okay, multiplied by the angular speed. Okay, in this case the frequency actually. Okay, let's see. Yes, so in this case, what is our amplitude? Have we been given the amplitude? Yes, we're told that it is 2 centimeters from its equilibrium position. Now 2 centimeters, you have to convert that to meters, because that's how we find the amplitude. Amplitude is measured in meters. So 2 centimeters, if it's 2 centimeters, you know that 1 meter is equals to 100 centimeters. So the centimeter can divide. So 200 divided by 100, that is 0.02. So I'm going to put 0.02 meters here, multiplied by the angular frequency here. What do we have as the angular frequency? Okay, maximum speed and the maximum acceleration. So the angular frequency we just found, we had to find that it was 20 radians per second. Okay, so basically it's the one that we're going to use, multiplied by 20. So multiplied by 0.02 multiplied by 20. Okay, that is what? That gives me 0.4. Since this is the speed at the maximum, that will be meters per second. Now let's find also the acceleration max. Okay, the maximum acceleration. Okay, now if this is the velocity, how are you going to find the acceleration? You're just supposed to square it. Okay, in this case it is the same formula, amplitude multiplied by the angular frequency squared. Okay, that is the only difference. So in this case, amplitude is 0.02 multiplied by V, which is 20. Our angular frequency, which is 20, this is squared. So now 20 squared, that is a 400. A 400 multiplied by 0.02, what do I get? I'm getting 80. This will be meters per square second. Okay, that will be the acceleration. So those are the two answers for this one. So the speed max, it is 0.4. The A max, or the acceleration max, it is 8 meters per square second. Okay. Okay, now V is asking us the speed of the mass when the spring is compressed by 1 centimeters. Okay, we're trying now to find the speed. So the way we find the speed though is very, very interesting. So we've been told that it's compressed by 1 centimeter. So we have to first convert that one to, because that's the displacement. Okay, so the displacement x, it has been compressed. So if it was like this, you've compressed this spring to about 1 centimeters. So now the displacement, what are we going to have? You're going to have now 1 centimeters, that is 1 divided by 100, that will give us 0.01 meters. Okay, that is the displacement. Now that we found this, I think we have everything now to find our, what are we finding? This is speed of the mass. Okay, so the way we're going to find the speed of the mass, so the speed will be equals to the angular frequency multiplied by the square root of amplitude squared minus the x squared that we're just from finding. Okay, so this is the formula. So now what is the angular? We found that it was 20. This is the angular frequency. Then the square root of our amplitude, we found that it was what? It is 2 centimeters, right? 2 centimeters, we said it is the same as 0.02, okay, meters. So it means it's supposed now to find 0.02 meters squared minus, then the one that we now are compressed, it is x, which is 0.01, even this one squared. So basically this is how we are going to solve it. 20 the square root of 0.02 squared, that gives me 0.0004. How many zeros? 4. Okay, minus 0.01 squared, this one will also give me 4 zeros, 0.0001. okay, then you're supposed to subtract the 2. Okay, okay, so what do I have? Let me just do it in advance. So 20 the square root of 0.0004 minus 0.0001. So what do I have? I'm getting my V, okay, as 0.35. Now since this is the speed of this mass, this will be meters per second. Okay, so that's how you're going to solve this one. So the last one is asking us to find the potential energy of the spring at its compression. Okay, so the way you find the potential energy in this case is called U or PE. Okay, now the way you find the potential energy, you know that it is half K multiplied by A squared. Okay, so in this case we're going to have half multiplied by the spring constant. We've been given that it is 1200, so I'm going to say 1200 multiplied by the amplitude squared. The amplitude, we say that it was, we were given that the distance, it is 2 centimeters, and when you convert 2 centimeters to meters, we know that it's 0.02. However, it is squared, so we are going to put a square like that, then you solve. Okay, so you know that 1 over 2 is just the same as 0.5. This is multiplied by 1200 multiplied by 0.2 squared. This one gave us 0.0004. We have 4 zeros. Okay, basically this is what you have. Then you multiply. So 0.5 multiplied by 1200. You know that the 0.5 is the same as the half, right? Half multiplied by 1200. The half of 1200, then at 600 multiplied by 0.0004. So now 600 multiplied by 0.0004. So I'm getting 0.24. Okay, since this is energy to be in joules, basically this is how you are going to find the answer for this one. Okay, let's start and go to question number 4. Now we are told that the car starts from rest and accelerates uniformly to reach a velocity of 20 meters per second after traveling 100 meters. It travels at this velocity for 750 meters and then takes 5 seconds with uniform deceleration slowing down to come to rest. Draw a velocity time graph and use it to find its displacement at that, and the total time taken. Okay, basically this is what we have. So if we're going to draw our velocity time graph, so what are you going to do? They've specified, so this side would be velocity, this side it would be time. Okay, now we're told that it started from rest, so this is 0, 0. So if it started from rest, it accelerates uniformly to reach a constant velocity of 20 meters per second. 25 actually. So it is moving, then it has reached 25. Let's say 25 meters per second is here. This is our 25. Okay. After traveling 100 meters. Okay. It starts from rest and after traveling 100 meters. So let's say it has traveled the 100 meters. Let's say from here to here it's 100 meters. Okay, so it travels. Time of this phase, have they given us? A car starts from rest and acceleration to reach a velocity after traveling 100 meters. It travels at this velocity for 750 meters. Okay, then it travels at this velocity for 750 meters. So let's say now from here to here it's 750 meters, and then takes 5 seconds with uniform acceleration. Okay, 5 seconds with the uniform deceleration, actually slowing down. So basically, if this is what we have, what are we now going to have? So this motion, you're able to see that it has 3 phases. It starts from rest, reaches a time of that. Okay, so what do we now have? So half base height, half multiplied by the base, in this case which we are trying to find, times the height, which is 25, is equals to I'm trying to find something, is equals to what is what have you been given? 100. Okay, so in this case this, if I multiply by 2 throughout, okay, let me say I multiply by 2 this, I'm trying to find, I also multiply by 2 on the other side, this and this will cancel. I'm going to have b is equals to 200 divided by 25. 5 into here, it is 5 into, that is 4. Okay, so basically I'm trying to find the time that it made in the first round. Okay, so you know that this is a triangle, so we have to find the time it took, and it gave me 8. How I found 8 is, you know that this is a triangle, and the way I find the distance is half base height, right? This is equals to the distance, or the area. Now the area in this case we've been given, the distance we've been given that it was 100 meters after it traveled for 25 seconds. Therefore I'm going to say half multiplied by the base is the one that we're trying to find, the distance from there to there. The height we already been given that it is 25. Okay, so I'm just going to replace, so I'm going to have the base which we're trying to find multiplied by the height, which is 25, is equals to 100 meters. Now what I'm going to do now is I'm going to have b multiplied by, now for me to remain with my, okay, what I did is I had to multiply by 2 on both sides. So when I multiply by 2 on both sides, what I have is that the 2 and the 2 are going to divide this side. I'm going to have b multiplied by 25, or which will give me 25b, is equals to 100 multiplied by 20 by 2, that is a 200. Okay, then I'm going to divide by 25 on both sides to find my b. So b in this case is equals to, I look for 2 numbers, 5 into 5 into 25, that is 5, 5 into 20, that is 40, 5 into 40, that gives me 8. So it means that for the first 25 of uniform acceleration, it moved 80 seconds. That's the 8 that I've written. Then we are saying this is 100 meters. Then we've been told that it travels at this velocity for 750 meters. So it travels 750 meters. 750 meters. Okay. What will be the time of this phase? Now this is a rectangle, so LB is equals to 750. Okay. Now what is the length? In this case, from H to, okay, the height we've been given. So the length is what we're trying to find, which is from H to here. However, what is the height? The height is 25 multiplied by 25. This is equals to 750. So the length in this case it will be 750 divided by 25. Okay. So I'm going 5 into 25, that is a 5. 5 into 7, that is a 1. 5 into 15, no, into 25 again, because into 7 it leaves a remainder of 2. 5 into 25, that is a 5. 1, 2, okay, 50. Then 5 into 150. 5 into 15, that is a 3. So it means for this time period it is 30. Okay. So from here to here it is 30. So for me to find the number here, it is 30 plus 8. So I'm going to write 38 here. Now, what is the last point? We're told that for the last one, it then takes 5 seconds with uniform deceleration. Now, it then takes 5 seconds with uniform deceleration. So it then decelerates to 5 seconds. So they've now given us, so from 38, we're just going to add 5 seconds. And 38 plus 5, that gives me 45. 40, is it 40 what? 43 actually. Okay, from here to here is 5 seconds. So basically, this is how you're going to draw your, this is your time in seconds. This is your velocity in meters per second. This will be your graph, okay? And that's how you're going to show it. Basically, a very simple question. 6 marks. Find its displacement in the first 20 seconds of the motion. Okay. So in the first 20 seconds of the motion. 20 seconds. So 20 seconds, where is our 20 seconds going to be at? Okay. So 8 to 20, let's say 20 somewhere here. We're just approximating. Okay, so it means the difference between 8 and 20, that is a 12, right, in this distance. Okay, plus the 8 here. So now we're trying to find the displacement. So what are we going to have? So in the first 8 seconds, the car covers 100 meters. We already know, we've already been given that. But now from here to here, the 12 seconds that has remained. 8 has already been covered. What about the 12? So I was supposed to find it for that 12. Okay, what will be the distance? Okay, so you know that from 8 to 12 to 20, which is 12 hours duration, it moves a constant speed of 25 meters. They've already given us. Okay, so in this case, what are we going to have? We're going to have LB is equals to the displacement in this case, which is from here to there. Okay, so what are we going to have, which is the displacement which we are trying to find? Okay, now the length, the height, this is the height, which is 25, multiplied by from here to here, we are saying it is a 12. Okay, so 25 multiplied by 12, will be equals to what? So that will give us 25 multiplied by 12, that is giving me 300 meters. Okay, so now we have this part as 300 and we have that part as 100. So what are we going to find now as the total displacement in the hot 20 seconds? So we are going to add your 100 plus 100 for the first 8 and for the last 12 300 meters. So in this case, what are you going to have? 100 plus 300, that gives us 400 meters. So therefore that will be the displacement for the that motion, that amount of time. Okay, now that we found that, let's go to B, find its total displacement. Okay, so now what will be its total displacement? So it means we're adding the 100 that we have. What other displacement do we have? Okay. Total displacement. So for the first phase it was 100 meters. The other phase, this one, it is 750. Then we have to find the other phase, this one. Okay, so what are we going to do to find us that one, the last part of the displacement? So this is also what? You know that speed is equals to distance over time. I'm trying to find for the last part. We're trying to find the distance. So it took. And what will be the distance? Distance in this case will be equals to speed multiplied by the time. Okay. So in this case it is the average speed. So it is the average speed. We're just trying to calculate the average speed. So in this case the average speed will be what? It will be what? 25 meters per second. The average of that is 2. Okay, multiplied by the time, which is, we're told that it took 5 seconds for it to decelerate. Okay, 25 divided by like 2, that is like the acceleration. Okay, I've put speed but it's the acceleration. You know that acceleration is equal to distance over your time. Okay, so that's what you know. Okay, now your acceleration in this case, 25 divided by like 2, then I'm multiplying the answer. 25 multiplied by 25 divided by 2, that is like 12.5 multiplied by a 5. What is going to be my distance in this case? 12.5 multiplied by 5 is giving me 62.5. So that is the distance that we're going to have. Now reduced chance, we're saying this one is 62.5. Okay, basically this is what we have. Or you can use the other way, the half base the height one, half base height is equals to the distance. Okay, do we have, let's say, half multiplied by the base from 35 to 43, we're saying it is 5, multiplied by the height, we said it is 25 meters per second, is equals to the distance. Okay, 2 into 2, that is a 1. 2 into 25, that is a 12.5. You're multiplying this by 5 and it's going to give you 62.5. So basically whichever method you're going to use, it is still the same. Okay, so now what is now the total distance? So the total distance will be the 100 for the first one plus the 750 plus the 62.5 that we're just from finding. Okay, these are in meters. Okay, so 100 plus 750 plus 62.5, I'm getting 912.5. 5. This will be in meters. So basically that will be the total displacement. Okay. Okay, otherwise if we would have wanted, we would have used the instantaneous where we differentiate, but because it's at uniform, we've been told that it's accelerating uniformly, we will not differentiate. Okay, otherwise that is another method that you can use. Now we're told now to find the total time taken. So the total time taken, you're just adding. We have from here to here we have 8 plus from 8 to 20, okay, and 5. So we've been told that it moved from here to here 8 from here to there, it is 30, moved 30 plus from 35, from 30 to 35 to 45, it moved 5. Okay, basically it's just 43 seconds. Okay, we've already found it. So that's how we are going to solve this question. So we come to the second question. An ideal gas is taken through a Carnot cycle. The isothermal expansion occurs at 250 degrees Celsius, while the isothermal compression takes place at 50 degrees Celsius. The gas takes in 1.2 times 10 to the power 3 joules of energy from the high temperature reservoir during the isothermal expansion. Find the heat energy expelled to the low temperature reservoir in each cycle of operation. And B, find the net work done by the gas in each cycle. So we have low and high temperatures. So what are you supposed to know? We're trying to find the heat that was expelled and the heat that was the heat that we need to work on. Okay, or the work that was done by the heat. Okay, basically this is not a very complicated question. So the heat that has been expelled to the low temperature, how are we going to find it? So first let's convert our temperature to kelvins. We've been given a low temperature. In the low temperature reservoir, what are we going to have? Low temperature reservoir, this is let's start with the high. High in this case, what have we been given as we've been given 250 degrees. Okay, the isothermal expansion occurs at 250, while the isothermal compression takes at 50 degrees. Okay, of energy, it takes from the high energy. Okay, it takes 50 degrees Celsius the gas. Okay, so for the high, we've been given that it is 250. That's the expansion one. It has expanded. So 250 plus, you know that when you're converting to kelvins, you're going to add 273. Now I'm not going to put points because I don't want to have a lot of work, but I'm just going to round it off. So 250 plus 273, I'm getting 523. This will be in Kelvin. What about for the low temperatures? Low temperature reservoir. Okay, in this case I'm going to say TC. Okay, now for the low temperature we've been given that is 50 degrees. That is the compression plus 273. So 273 plus 50, what do I have? I have a 323 Kelvin. Okay, this is what I have as the low and the high temperature. Now how do you find the Carnot efficiency? The Carnot efficiency, there's what we call the Carnot efficiency. So the efficiency in this case, which I'm going to just represent as that, which is E, it is 1 minus what you have as the compression, then what you have as the expansion. Okay, temperature in this case. So in this case we're just now going to solve 1 minus. Now let me find TC and T3. TC, we found that it is, in terms of compression, we found that it's 323 Kelvin. Then for the expansion one, we found that it is 523 Kelvin. Okay, basically this is what we have. We're going to have 1 minus 323 divided by divided by 5. Pardon me on that one. Let me try again. 323 divided by 523. Okay, what do I have when I divide that? I'm getting 0.6174. So this is the one that I'm subtracting from 1. 1 minus 0.617, I'm getting 0.3826. Okay, now that I've found this as the efficiency, and I'm now supposed to find the heat that was expelled. Okay, so this will help me to find what the heat that was expelled. So where can I write? Okay, now allow me just wrap this part. Okay, so now the heat that was expelled, we use also a certain formula. Okay, and that is very, very important for you to know. Okay, so the way we find the heat that was expelled, heat usually we express it as Q or C. In this case, the QC in this case will be equals to what have we been given? We've been given, let me say if we've been given, okay, we've been given the energy of the gas, okay, which is even better. So that energy is called your energy of expansion. That one is Q. What is our Q in this case? It's our QH. Okay, in this case we're multiplying this. We're going to multiply by the temperature of compression divided by the temperature of expansion. Okay, so in this case our QC that was expelled, I'm going to have 1.2 times 10 to the power 3. You know that is just the same as, okay, that is just the same as I'm multiplying by 1,000. So in this case I'm going to have 1.2 times 10 to the power 3 joules. Now we've already found what TC over TH is, the temperature of compression divided by the temperature of expansion. And what did we find when we were dividing? Okay, what did we find when we were dividing? We had to find that it was this one here. So I'm just going to replace it here. So this is multiplying by 0.6174. Okay, so our job is just to multiply. Okay, so now 1.2 times 10 to the power 3, that's giving me 1200, multiplied by 0.6174, it is giving me 740.9 joule. Okay, because the temperature in this case, the Kelvin and the Kelvin are going to cancel, so we're just going to have the joules as remaining. So in this case that will be the heat that is going to be expelled. Okay, so we found the first one, heat expelled, 740.9 joules. Okay, at least we've already found our efficiency, so this will help us to find the work. Okay, so now let's have the last question. So the work in this case is going to be the energy that was released, which is, we said that this one is QH, minus what do we have on the other side, minus the heat that was released. Okay, the heat that was released, QC, that is the formula of the work. So in this case the total work that will be done, therefore the energy that we had put was 1.2 times 10 to the power 3 joules, minus how much was expelled, 740.9 joules. Okay, so therefore you're just going to subtract the two. So I'm saying 1000 200 minus 740.9. I'm getting 459.1. This is the work, so it will be in joules. Basically, this is how we're going to find the work for this question. Let's solve question number 5. Okay, so for question number 5, we are told that a 1 kg block starts sliding up a 35 degrees inclined plane with an initial speed of 3 meters per second. It stops after sliding 50 centimeters and then slides back down the incline. Assuming that the friction force impeding the motion of the block is constant, find the friction force and the coefficient of kinetic friction. Okay, if 1 kg block starts sliding at a 35 degrees incline with an initial speed, it stops sliding after 50 centimeters and then slides back down the incline, assuming that the friction force impeding the motion of the block is constant. Find the friction force and the coefficient of kinetic friction. So assuming it goes up the incline, it has gone, the angle we've been given that is 35 degrees. Okay, it has gone up. It was moving at 3 meters per second. Okay, this is a 1 kg block. It is moving at that and it slides to about 150. It slides to 50 centimeters. Okay, then after it had reached that, it had to stop and again go back. Okay, now we're trying to find the friction, and number 2, we're trying to find the speed of the block when it reaches the bottom. Okay, use conservation of energy method. Okay, so they're specifying what you're supposed to use. So whenever they specify, use what they've given you. Okay, so now let's solve the friction force. So what do we know? Mass, we're given 1 kg. What about the speed on the plane? The initial speed, we're given that it is 3 meters per second. The distance we've been given as 0.5 meters. Okay, then the angle we've been given that it is 35 degrees. Acceleration due to gravity is going to be affected by gravity because it's going against height. So this is 3 meters per second. Okay, so now what are we going to do as to find us the frictional force? Okay, this is a very, very interesting question. Okay, you know that friction force, we're just from talking about friction force. Okay, friction force is equals to the coefficient of friction, in this case is it kinetic, okay, multiplied by coefficient of kinetic friction. Okay, so it nu k multiplied by the normal force. Now we're supposed now to make the friction force and the coefficient. Find the friction force and the coefficient of kinetic. So we're trying to find we're trying to find two here. We're trying to find the friction force and the coefficient of kinetic friction. Okay, so we're going back now to our principles. So you know that what was the kinetic energy initially when this object was moving? Kinetic energy is equals to half mv squared. Okay, so in this case it will be half multiplied by the mass. In this case, what is the mass? Initially the mass have been given, it's 1 multiplied by the velocity. Initially it was 3 meters. It was 3 meters per second. So that is what we have as the kinetic energy. So this is half 1 multiplied by 3 square. 3 square, that is a 9. Okay, the half of 9. What is the half of 9? 9. That is like 4.5 joule. Okay, that is the kinetic energy that we have. Now what will be the work done against the work that is going to be done now against gravity? Work done against gravity. You know that work done against gravity is mgh. Okay, So in this case, the work done against gravity, what are we going to have? Okay, so what are we going to have? The mass, we've been given that it is 1 multiplied by the acceleration due to gravity is 9.8 multiplied by the height. What would be the height? So if this is a block, this is 35 degrees, okay, and this is the height. So for us to find us this will be 35. So this is the hypotenuse. So we have a SOHCAHTOA. So sine is equals to opposite over hypotenuse. Okay, so we're going to use the sine. So sine is the one that is going to give us the height. So for us to find the height, we're going to say it is going to be s, what we have as a distance, which we've been given as is it 0.5? Okay, it's 50. What did I write? It is 50 centimeters. Okay, so it's going to be s 50 centimeters sine. In this case, we have 35 as the angle. That would be the height. So it would be 1 multiplied by 9.8 multiplied by s, we're given as 50 centimeters. 50 centimeters, you're supposed to convert it to meters. So you know that you're dividing by 100 and 100. 5 divided by 10, that is 0.5. So 0.5 sine 35. It is giving me 0.287. This will be meters. Okay, now that I've got that, okay, now that I've got this, I'm going to multiply it by 9.8 actually. So the answer that I have, 0.287 multiplied by 9.8 multiplied by 1 I'm not going to put it, it's just the 1. Okay, so multiplied by 9.8, it gives me 2.81 joule. So basically this is what we have as the work done against the gravity. Okay, now that we found the work done against gravity, let's now find the energy that is available. Allow me to wrap this part. We said this is the kinetic energy initially. We said this is the work done or the potential energy, okay, due to height. Okay, so now how are we going to now find the energy that was lost and want to find what was available? Okay, so initially we had the kinetic energy, which was 4.5 joules. Okay, this should be equals to the energy that has been done just to gain a potential energy, which is 2.81 joule. Okay, 2.1 joule like that, plus the friction that they're asking us to find about. Okay, the friction force. Okay, so what are we going to do now? You know that the friction force is you know, your friction, in this case the work done by friction. Actually, let me put it nicely, work done by friction. Work done by friction, you know that friction work is equals to force multiplied by the distance, but now in this case we're talking about the friction force, okay, multiplied by the distance. So I'm going to replace it here about for the friction force, because those are the forces that are acting on this object. Okay, now we have 4.5 is equals to 2.81, the friction force multiplied by the distance. So in this case, plus the friction force that we're trying to find, okay, the friction force due to kinetic energy. I can even put Fk because it's a friction force due to kinetic energy multiplied by the distance. The distance we are saying it's 50 centimeters. 50 centimeters is the same as 0.5 meters. Okay, then we solve. So I'm going to have 4.5. I'm going to take the 2.8 to the other side. I'm going to have minus 2.81. The way it is equals to friction force due to kinetic multiplied by 0.5. I'm going to divide by 0.5 on both sides. 0.5. So therefore our friction force due to kinetic will be equals to 4.5 minus 2.8. So 4.5 minus 2.81, I'm getting 1.69. This I'm dividing it by 0.5. Okay, so what will be my Fk, or friction force due to kinetic energy? So 1.69 divided by 0.5, this is giving me 3.38. This will be Newton. That will be the friction force. Now for us to find now the coefficient of kinetic friction, how are we going to do? We have been given, now we have almost everything. So you know that the coefficient of kinetic friction, we said it will be your friction force divided by your normal force. Okay, because friction itself, friction force is equals to your nu multiplied by the normal force. So if you make this one the subject of the formula, you're just going to have n on both sides. That's why I'm writing that, just to remind you. So now that we've got this, what do? We've already found our friction force, which is 3.380 Newton, divided by the normal force. You know that it is mass times acceleration due to gravity. Now what is the mass? I'm just going to replace the mass. What have we been given as the mass? The mass we've already been given as 1 multiplied by the mg 9.8. Okay, 9.8. Now don't forget that there is an angle here. Okay, so because there's an angle, it is going to be mg cos that angle. Okay, so that is very important for us to also write, because there's an angle that has been mentioned. So to be cos, what angle have we been given? Cos 35. Okay, so in this case we're going to have 3.38 Newton divided by 1 times 9.8 times cos 35. What is it giving me? So down I'm getting 80.03. So I'm supposed to divide it into 3.38. So 3.38 divided by 8.03, it gives me 0.42. So this will be the coefficient of kinetic friction for this question. Okay, now that we found that, is the second question asking us to find anything in relation to this? We're told to find the speed of the block when it reaches the bottom. Use the conservation of kinetic energy. Okay, so let's solve that one. So what will be the speed at the bottom? Okay, we know that the speed at the highest point that you can have, in this case for this inclined plane, when it reaches the highest point, you know that the speed at that point is 0, right? Okay, however on the way down, as it is coming down, okay, because this object had already gone up, but now again it's coming down. Okay, now as it is coming down, you're able to see that you are losing your height. So because you are losing your height, you are losing gravitation potential energy. Okay, and as you are losing that gravitational potential energy, you'll be experiencing a lot of friction going this side, work done by friction. So those are some of the concepts that you're supposed to understand. Okay, so in this case you had your mgh when you are, let me just explain it again. This is the object has gone up. When it reaches here the speed will be 0. Okay, now it wants to come, when it wants to now start coming back. So initially, what energy does it have on top? It has mgh, because there is height that has been gained. So it's now going to, as it is going like this, it is now going to be losing that height. So all the energy is going to be conserved. That's why they're asking us to use the conservation method. All your kinetic energy is going to be now converted to the work that is going to be done in this case, okay, due to kinetic energy, due to potential energy. So in this case, what will be our answer? So we're going to have mgh, the potential energy, which is mgh. We've already found it, that is 22.81 joules. Okay, it is the same as the one that we had before. However, what will be the work that is going to be done by friction when you are coming down? Okay, so when you are coming down, it will be the friction force due to static. Okay, friction force due to kinetic. Okay, work done by friction. So what are you going to have? It will be the friction force work is equals to the friction force multiplied by the distance. So this will be multiplied by the distance. The friction force, we've already found that it was that. So this is 3.38 Newton multiplied by the distance that is going to move. Is still going to move the same distance, 0.5 meters or 5 centimeters, which we converted. So now when we now do the math, 3.38 multiplied by 0.5, I'm getting 1.69 joules. This will be the work that is going to be done by friction. Okay, now that we've got that, energy is always conserved. So all these energies that we have, the potential energy, the work that has been done by friction, what are you going to have as the final energy? Okay, now the energy that you have as potential energy, it is slowly being converted to kinetic energy. So therefore, you're going to have the change in kinetic energy will be equals to the energy that you have as potential energy minus the friction force, because you're also experiencing the friction force as you're coming down. Okay, so in this case, the potential energy, what did we find as the potential energy? mgh is 2.81 joule minus the friction force. The friction force, we have found that it is what? It is 1.69 in this case. Okay, the one that we're just from finding. The work done by friction. Now that we got this, we're just subtracting 2.81 minus 1.69. It is giving me 1.12 joule. That is the energy that we have due to kinetic. Okay, so now that we've got this, we can now find the speed. Okay, because we have the kinetic energy. You know that kinetic energy is equals to half mv squared. We found the kinetic energy to be 1.12 is equals to half multiplied by the mass. The mass we've told that is what we've been told is 1 times the v, which we are trying to find. Okay, in this case, half is 0.5. 0.5 multiplied by 1, that is just 0.5. So what do I have as my v squared? What am I now going to have? Okay, so, or I can just multiply by 2 on both sides. Even this side multiply by 2, so that the half and the 2 goes. So I just remain with my v squared this side. Okay, 2 multiplied by 2.12, 2 multiplied by 2.12, I'm getting 2.24. So I'm supposed to find the square of that on both sides. Therefore my velocity to be the square root of 2.24. The square root of 2.24 is giving me 1.5. So this is 1.5 meters per second. So basically this will be the velocity or the speed that you are going to have at the bottom as you are coming down. All the potential energy that you had, it is going to be converted to kinetic energy. However, you are going to experience some friction force, which will be the work that is going to be done by friction. So basically this is how you solve this question. Okay, now we are told, this is question number 6. We are told a gun of mass 4 kg recoils or pushes back with a speed of 0.5 meters per second when it fires a bullet of mass 10 grams horizontally. Find the speed with which the bullet is fired. Okay, so we're trying to find the speed of the bullet. Okay, so the mass of the gun, have we been given? The mass of gun, let me just write mass gun. The mass of the gun, which we're going to call M1, it is 4 kg. We're saying it recoils at what? At 0.5 meters backward. Okay, because recoiling is they've told us it pushes back. Okay, then it fires at the bullet of mass 10 kg. We have another mass of the second bullet, which I'm going to call M2. In this case, we've been given that it is 10 grams. The 10 grams we're supposed to convert it to kg, right? So we're going to divide by 1000, and I'm going to get 0.01 kg. Okay, then the V2 is what we don't know. Okay, find the speed with which the bullet is fired. Okay, so how are we going to find the speed? We're going to apply the conservation of momentum. Okay, now initially the momentum is what? It is 0. Okay, because this thing is recoiling back. A gun of mass 4 kg recoils, pushes back with a speed of, when it fires a bullet of 10 kg, find the speed with which the bullet is fired. So the initial momentum will be 0. Okay, in this case, what are we going to have? Initially it hasn't moved, right? That's what I mean. The initial momentum will be 0. Okay, so this whole expression, initially, what did we have? Okay, what we had initially, we have mass 1 and mass 2. Okay, so mass 1 multiplied by momentum, you know that it's a mass in motion. Okay, mass in this case mv, motion is velocity. So mass 1 at the velocity of 0.5, we're going to add it plus the momentum, the mass of the momentum of the second one. We have mass 2 multiplied by v2. This expression is goes to 0 initially. Okay, so in this case, initially we're trying to find the velocity of the bullet when it is just fired initially. So what do we have? We're just solving now for the 2. Okay, so when we solve for v, what do we have? For v2, I'm going to have what am I going to have? Okay, I don't want my negatives. Okay, so I'm going to have m2 v2 is equals to m1 0.5. Then for me, I'm going to now divide by, I can even put a minus c, although that doesn't, mass as a negative doesn't make sense. Okay, so I'm going to now divide by 2. I'm finding v2, I'm going to divide by m2, because we know the mass for the second ball. So the mass for the first ball, m1, we've been given that it is 4 kg. We're multiplying this by 0.5 over m2, it is 0.01 kg. Okay, so now what are we doing? 4 multiplied by 0.5, or the half of 4, that is a 2, over 0.01. When I find that 2 divided by 0.01, it's giving me 200. Since this is the velocity, it will be meters per second. That will be the initial velocity for the first one. B, we ask that if the bullet embeds itself in a 1.99 kg block of wood at rest on a horizontal table, with what velocity does the block and bullet begin to move? If the bullet embeds itself, so now that the bullet has embedded itself, so what are we going to have? It means we have inelastic collision. Okay, now you can watch our videos on momentum. You're going to find all these videos where we're explaining about this. So m, the mass of the block and the mass that we had initially. So the other mass that we had was 10 grams, which we found that is 0.4. Now let's say now this bullet embeds. Okay, so we're going to have the mass that we had as 0.01 plus this mass that has embedded 1.99 kg. Okay, when we add the two, 0.01 plus 1.99, it gives me 2 kg. Okay, so if it is giving me 2 kg, what are we going to now have? We're going to now have we are going to use the conservation of momentum just before and just after embedding. Okay, so what are we going to do? We're going to have our mass 2 multiplied by the v2. Okay, this will be the final mass multiplied by the velocity. Why? Because the masses themselves are going to add up. Okay, the momentum, initially it was like this, but now we've added another mass. I'm just adding a mass to mean that there are 2 now. So what are we going to like have? I'm supposed to find the what I'm supposed to find the what? If the bullet, what is the final velocity? So I'm trying to find the final velocity. They are going to move with the same velocity. Okay, so I'm dividing by mass. What am I doing? I'm dividing by mass, the total mass. Okay, so the final velocity, which will be the same for both the bullet and this thing that we're shooting at, the box. I don't know if it's a block. So in this case we have m2 v2 over m. Okay, then we're just from finding our v is it we have to find like 200. Okay, so we're going to get the mass. The mass for this one, we've been told that is 0.1. We're multiplying it by the velocity. The velocity for the second ball, we found that for the second, it fires a bullet mass horizontal. For this second mass, it is 200. We just found that. Okay, so basically that's what we're also going to write here. Multiplied by 200. Okay, divided by their combined mass. Their combined mass, because they'll be moving together now, that is a 2. Okay, so 0.01 multiplied by 200, that is giving me a 2 divided by 2. 2 divided by 2, that is a 1. So therefore the velocity final for this ball and the bullet, they are going to be moving at 1 meters per second. Basically this is how you solve this one. Okay, question B, we're told if the block and the bullet stops after 10 centimeters, what is the coefficient of sliding friction between the block and the table? If the block and the bullet stops after 10 centimeters, what is the coefficient of kinetic friction between the block and the table? Okay, so this is a very, very interesting question as well. So initially, what is the kinetic energy? I always like finding the kinetic energy because it just simplifies things. Okay, multiplied by v squared. V final squared. So what did we have? WAF multiplied by what was the mass, the total mass if the block and the bullet stops. So the total mass of the bullet and the block, we found that it was 2, multiplied by the v squared. What is the v squared that we have? We're just from finding it, the final velocity at which they are moving at, it is 1 second. Okay, so we're going to square that. Now if we still have 2 divided by 2. Okay, 2 divided by 2, that is just the 1. So we're going to have 1 joule as the kinetic energy. What about the work that is going to be done by friction? Because it's on a table, so work done by the friction will be what? Friction force multiplied by the distance. Okay, since it's on a horizontal table like that, on its block and the table, okay, there's no aspect of a of an angle. So in this case, what will be the friction force? Okay, you know that the friction force in this case, it is nu by minus the multiplied by the normal force. The normal force is mass times the acceleration due to gravity multiplied by d. So I just replace it. So now we're trying to find the coefficient of kinetic friction. Okay, so you know that there's what we call the work energy theorem, right? Work is equal to the change in kinetic energy. So in this case, this is the kinetic energy. It is also the same as the work done by the friction in this case. So we're going to have 1 joule. Okay, so that is what we have. So we're dividing that 1 joule by everything that we have on the other side. We have U, M, G, D. So we're multiplying by what we want to find the coefficient first. So we're going to divide by M, G multiplied by D. So these are going to cancel. So what is now going to be our coefficient? So the coefficient of kinetic friction in this case would be 1 divided by the mass of these two balls. We said that it is 2. Okay, multiplied by the acceleration due to gravity 9.8, multiplied by the distance that they moved. They've told us that they stopped at about 10 centimeters. 10 centimeters are supposed to convert it to meters. So we're going to divide 10 divided by 100. That just gives us a 0.1. Okay, then you just solve 1 over. Let me now multiply 2 multiplied by 9.8 multiplied by 0.1. I'm getting 1.96. This is equals to, so I'm now dividing 1 divided by 1.96. 1 divided by 1.96. I'm getting 0.51. So this will be the coefficient of kinetic friction. Basically, this is how you solve this question. So I think we're going to end from here. These other questions, we'll post them on the drive, and the other thing is we're going to add a link to the solutions for this exam paper in the comments section. Then you're going to check up on question number 7 and how we solve it. Basically, we've done just this. We've done from the 6 questions. We've answered 5. So basically, this is where we're going to end from for today. Thank you, and see you in the other sessions.